So in order to do that, I'm going to set up a couple variables. First, I'm just going to set up like some true and false statements to make sure we keep track of what part of the file we're reading. So we could be reading the data. I'm going to start off, we're going to say it's false. We could be reading the standard curve. We could also be reading the data definition. Okay, so I'll set all those to false to start. And so then we do want to set up our patterns to decide when we're reading these things. We know we're going to start reading our data pattern when we see that line of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we can make this pattern by using RE, the regular expression module, and using the compile function. Okay, and so that will compile a regular expression for us. And so like I said, they were just numbers separated by tabs. And so tabs are these backspace T. Just like end align's backspace N, a tab is backspace T. And so this is what that line was. It was tabs with all these numbers between them. And so we know if we find that pattern, then we're going to be reading the data on the next line. And similarly, we can set up a pattern for the standard curve definition and the data definition. Okay, if we go back here, we're basically looking for standard curve definition. Okay, and so this sets up these patterns that we're looking for. And so now what we want to do is, as we go through our lines, we want to search and decide if we've matched the pattern or not. And so I'm just going to use very generic terms. M1 equals data pat, and see if it matches the line. And the same thing, we can see M2 not data pat, standard curve. So if we find a match, these variables M1, M2, and M3 will contain the match that it found. And so really, we just want to say if M1 has anything other than none, right, then we are definitely know we are now reading the data. So we can set that to true. You know, otherwise, we can use elif. If M2 is true, okay, we know we're no longer reading the data. So I can set that back to false. But now we are reading the standard curve definition. Okay, otherwise, if we find the data definition, we're not reading the other two, just to make sure. Okay, and so that sets these variables so that we know which part of the file we're reading. We've defined where you are in the file, and so the thing I can do is now we can say if reading data, right? I can just make this a comment. I'll put pass for now. Doing this lets us kind of parse out which part of the file we're in and then do the specific commands we want to do while we're reading that part of the file. I know the script is really empty, but it gives you sort of a framework that you can work with to start to do things about reading the file and setting it up and decide how you want to output the data after that. Again, you should probably organize all this into functions, like all this might go into some read data function. All the input you need is just in the user's read spectrophotometer data. So if we run this, okay, so I got an error. You can see I didn't put an underscore over there. So you should not feel bad getting these types of errors. Everybody gets them. I run, and so now it ran and read. We can even put some print statements here. To let us know that we found the data. Okay, and we can get rid of these pass commands now because we're actually doing something. So this will just kind of make sure that our script is working and that we're able to find all the parts. So that works great. And now you guys can proceed to analyze the data and produce the plots I ask you to.